Yeah. So, in the earlier class, we have already seen how to construct the Hasse diagram. Then I asked certain question. Hope everyone have solved that. Let's go ahead with respect to that Hasse diagram. There are certain key components or key technical words, technical keywords that are represented in Hasse diagram. So, A is a maximal element in the poset if there is no B belonging to that set S such that A is related to B. Related to 4. 4 is related to 2. 2 is related to 1. 3 is related to 1. 6 is related to 3. 12 is related to 6. So what is meaning of maximal element? It is basically an element A in the poset is A is related to A is less than or equal to X, or I mean say A is less than or equal related to partial order relation with X for no X in P. That is if no element of P is strictly succeeding A. So when we draw the Hasse diagram, it is basically with respect to some relation. And when we say something like less than relation, so we can see 1 comma 1 2 comma. I will take one simple example. So relation R on set A that is equal to 1 comma 3 comma R is less than or equal to R is equal to. So therefore, when you draw the Hasse diagram for this, you will have the relation something like this. So your relation R is less than or equal to, and your set A is given to you 1 comma 2 comma 3 comma 4. Okay. So less than or equal to is the relation. So you can see now here the relation A R B. So one is less than or equal to B, less than or equal to B. This is the relation. Now if you go with this one, 2 is related with 3 is related with 4. Now you can see that there is a relation 1 R 2, there is a relation 2 R 3, there is a relation 3 R 4. Reflexivity also, that is each element. So you can guess the maximal element is nothing. What is that maximal sum? Apart from itself, it is not related with anyone. So in this case, and one is your minimal element. This is called and this is called as maximal element.
sir,
Okay,
your screen is freeze.
pardon? Yeah, any.
सर स्क्रीन रुकी हुई है, फ्रीज हो गई है सर.
Wait. Okay. Hope the screen is visible now. Is it visible?
Yes sir, yes.
Yeah. Ahead, what exactly we are talking in this, the maximal and minimal element. You have been given one poset, that is, a poset is nothing but a set having partial order relation R. So you have been given that poset S and some partial order relation R. A belonging to that poset is called maximal if there is no B belonging to S such that A is related to B. Okay. So in that case, we say A is maximal element. Similarly, what is minimal element? If an element of a poset is called minimal if it is not greater than or greater than any element of the poset. That is, A is minimal if there is no element B belongs to S such that B is related to A. So in this, you can see the element 1 is the minimal element to which no other element is related. There is no element which is related to 1. There is no element 8 is related with someone. There is no element 12 is related with someone. So therefore 8 and 12, they are maximal element. 1 here is minimal element. It is possible to have multiple minimal and maximal element. In this case, you are having two maximal elements and one minimal element. So these are the three keywords, two keywords you should know, maximal and minimal. Maximal means what? It is an element which is not related with anyone. Minimal means what? It is that element to which no other element is related. That's it. So what is greatest element? Least element. Greatest element and least element. So A is the greatest element in the poset if B is related to A for all B belongs to S. Means what? For if all B are related to this A, then we say it is the greatest element. If you do have at least one B which is not related with A, then A cannot become the greatest element. Similarly, an element of a poset is called the least element if it is less than or equal to all other elements in poset. Least element. Okay. Similarly, you can see here that 8 is for 8, 12 is not related with 8. Therefore, 8, though 8 is the maximal element, it is not the greatest element because to become this greatest, rest of the elements should be related to that element. Similarly, 12 is also not a greatest element because 8 is not related with 12. So that's the difference between greatest and least element compared with maximal and minimal. Is it clear? Please let me know. I will post some exercise. That time I will understand. Go ahead with upper bound and lower bound. This is one more concept that you should understand. Sometimes it is possible to find an element that is greater than all the elements in the subset A of a poset. Once I show you some example, yeah, here. So considering element 1 and 3, okay, considering element 1 and 3, so upper bound of 1, what is the upper bound of 1? You can, 1 is related to 2, 1 is related with itself, that is 1 is related with 4, 1 is related to 5. So for upper bound of 1, it is all the elements B so that A is related with B. So we want to find out upper bound of, we want to find out what is the upper bound of, what is the upper bound of A. So you see, it is basically collection of all these B's, so that A is related with B. So what is upper bound of 1? In this case, it is 1, 2, 4, 5. Similarly, what is upper bound of 3? That is 3, 2, 4, 5. Now, what is the upper bound of 1 and 3 together, if I say? So, we want to find out what are those B's such that 1 is also related to that and 3 is also related to that. So, you can see it is 1 is related to 4 and 3 is related to 4. So, it is also and it is also. So, 2, 4, 5 are upper bound for 1 and 3. To clear this. Okay. let us go step by step. What is lower bound? If I say I want to know what is the lower bound of phi. What is meaning of lower bound? So when I say lower bound, I give some input, that is lower bound of B. So it is collection of all the element A such that A is related to B. So what is the lower bound for phi? It is 2, 4, 1, 3. Every elements are related to phi, so that is the lower bound of phi. If I want to find out lower bound of 2, it is 2, 1, 3. It is lower bound of 4, it is 4, 1, 3. Lower bound of 1, that is only 1. Lower bound of 3, that is only 3. If I want to find out what is lower bound of 5 and 4, it is basically, it is together. It is basically 4, 1 and 3. What is lower bound of 2 and 4? So it is 2, 4, 1 and 3. Okay. So let me come back to this definition again, where we are right now. So let me recap what we discussed up till now. What is minimal element? What is maximal element? What is greatest element and what is least element? In this example, we do have only least element. There is no greatest because 12 is not related with 8. Therefore, this is not a greatest. Similarly, 12 is not greatest because 8 is not related with 12. Going ahead, what is upper bound and lower bound? So what is upper bound? It is possible to find an element that is greater than all the elements in a subset A of coset S. If U is an element of S, so what is the upper bound of U? It is all the A that are related with that element. Okay. So then we say if U is an element of S such that A is related with that for all elements A belongs to A, then U is called as upper bound of A. Means we want to find out all the elements belonging to A such that this set A is all the elements belonging to this set A, which is this set A is subset of coset. All the elements belonging to this set A are related with this element U. Then we say this U is an upper bound of that A. Similarly, there may be an element less than all the elements in A if L is the element of A such that L is related with A. L is less than or equal to A, you can say. For all elements belonging to that set A, then we say L is called as lower bound. That's it. Now, the element X is called least upper bound of the subset A if X is an upper bound that is less than every other upper bound of A. So coming back here in this example, let me take one example and we'll clarify in the paint. Okay. Make it clear. Let us say this is your one element, and this is your another element. 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 And let us say this is your another element. Fine. And let us say this is your element F. This is F. This is, let us say D. I'm just labeling this E. This is B. This is A. And this is C. So A is related with B. A is related with C. B is related with D. B is related with E. D is related with F. E is also related with F. And C is related with E. I will ask certain question now. Wait. Yeah, Chetan, unmute your.
Yes, sir.
Yeah, Chetan is there. Okay,
Yes, sir.
I
Yes.
think my screen is stopped. I will again. Yeah, yeah, wait. There is some issue at my side related to network. Okay, I hope the screen is visible now. So Chetan, let us have some
Yes.
interaction. Now, in this Hasse diagram, what is the maximal element?
Yes, sir. It's belong to itself, no?
Hello,
Hello.
Chetan, waiting to hear from you. Yeah, tell me, what is the maximal element?
Sir, maximal element is A. It's belong to itself.
No. Here, now you do have the relation A less than or equal to B. So here, basically, let's try to understand when you are looking to this Hasse diagram now, uh, you are having a relation now A to B, B to D, D to F, A to C, C to E, E to F. It is, wait, where is the pen? It is like this now. A is related with B when you say it is A is here now and B is here. Okay? So this way we say A is related with B. So now tell me the uh, what is the maximal element in this case? Your Hasse diagram is now interpreted in this direction. A is related with B. Yeah,
Sir,
Chetan,
B is related to A.
we are reading this relation A to B from bottom to top. A
Yes, sir.
is related with B. This is the interpretation.
Yes, sir.
It is
हेलो सर
max.
वॉइस आपका ब्रेक और
A is so which is that element? Yeah. what is that element in this Hansen diagram is maximal element. Yeah, Chetan.
Yes, sir. A little bit confused, sir.
Yeah, tell. Repeat. There is no. If the A to B. Yeah, Chetan, be louder now yourself. This first
Yes,
line.
sir. Sir, your voice is breaking, sir.
Yeah. Uh, you be
Hello.
louder. Read out this.
Yes, sir. A is a maximal in the
Uh,
poset
uh,
S,
yeah.
comma
Read out.
partial order
Read out
relation.
this.
If
Hmm.
yes, sir. Yes. A is a maximal in the
Continue
poset
from this. A is
uh,
a maximum.
S.
Hmm.
Yes, sir. A is a maximal in the poset S, comma partial order relation. If there is no B belongs to S,
Hmm.
such that A related to B. Similarly, an element of a poset is called
A
minimal.
is related to B.
Uh, Similarly, an
Wait,
element
wait.
of a
Let us
poset.
come back to maximum only. We will complete maximum.
Okay, okay.
Wait, wait, wait. Now we need to identify maximum. I, uh, yeah. In this hierarchy.
Yes, sir.
Hello. Yeah, tell element now in this. Hello.
Hello. Hello.
Yeah, Chetan, tell me. What is the maximum element? Yeah, I am able to hear you. Tell me.
Yes, sir. Sir, B.
I want to know. It is that element, maximal element, such that it is not related with anyone. So in this case, you do have F is called maximal because not related with someone. Hello.
Hello, sir. Your voice is breaking.
Okay. Yeah. Uh, so what is minimal element is? Minimal element is only A because no other elements are related to A. Okay. Now we want to identify what uh, upper bound of A. What is upper bound of A? It is collection of all the elements B belonging to this set S such that A is related to B. So can you unmute now? I hope I'm audible now.
Hello. Hello.
Yes. Now what is upper?
Sir, upper bound, no?
Yes, of A.
Sir, A, B, C.
It is basically a. Hmm, hmm, hmm. It is all those elements to which A is related. So A is related to whom in this case?
Sir, A is related to B, C, and itself A.
And F also. Okay.
Yes, sir. All the. Hello, sir. You are not audible.
Are you able to hear me now?
Yes, sir. Yes, sir. Now it's audible. Now audible.
Comma D, comma E, comma F. Now, similarly, upper bound of you want to find out E, it is basically equal. It is E, comma F. You want to find out upper bound of D. Upper bound of D, it is basically equal to D and F. What is upper bound of F? Upper bound of F is equal to F only. Okay. Similarly, you can find out uh, upper bound not only for single element but for combination of the element. If I want to find out what is the upper bound, so it is E comma F. You may have certain situation like I want to find out what is F and C. In that case, it is only F. Okay. Similarly, you can have lower bond also. Let us take some example of lower bonds. Lower bound of A, it is only A. What is lower bound of B? It is B and A. What is lower bound of D and C together? So the lower bound of D and C together is A. What is lower bound of F and A? Let us say lecture. Lower bound of F and A, that is equal to, you will get the lower bound is only A. That's it. You may have another example. Let us say lower bound of F and D. Let us take one more element, that is Z. I want to find out lower bound of all these three together. So F, D, and E, the lower bound is, you can see now here, we want to find out what are those elements who are related to F, D, and E, all these three elements. So, of course, you can see B is related with E, B is related with D, B is related with F via D and E also. So, B is your element of lower bound. Similarly, if you take C, no way C is related with D. C is related with E, C is related with F, but C is not related with D. So, therefore, C cannot be a lower bound of this subset of poset. And if I take A is related with D, A is related with E, as well as A is related with F via D and E. So A will also come there. So this is your final this that I'm presenting here as a lower bound of we already E, that is this. So in this we want to find greatest lower bound. What is greatest lower bound of F comma D comma E? So the greatest lower bound
Your screen freeze earlier.
bound is B and A.
Paint this time a little.
Bound is B and A. Hello. Yeah, anything.
Screen is freezed.
So yeah, anything. So you need to identify the lower bound. Okay. I don't know what is problem. So the greatest lower bound is what? In this, what is the element to which all other remaining elements are related? So B is the element to which B is related as well as A is related. So the greatest lower bound is B. If I take upper bound of A, upper bound of A is what? As we already discussed, A comma B comma C comma D comma E comma F. So we want to find out least upper bound of A. That is equal to what? Now, what is that element belonging to that upper bound of A, such elements belonging to upper bound of A. So you can see in this upper bound of A, you want to find out the least upper bound of A. The least upper bound of A you can have in this example, that is